What's going on, everyone? Welcome back. Patrick here, moving on to the next question. So Sarah just wrote a test where each question was worth 1 mark. And we have two scenarios here, so two different questions. If she scored 84% and answered 4 questions incorrectly, how many did she answer correctly? And then number 2, if she scored 62.5% and answered 18 more correct questions than incorrect ones, how many marks was the test out of? So starting with number 1 here, we're told that she wrote a test. She scored 84% on it and she answered 4 questions incorrectly. So she wrote a test and she had correct answers and then incorrect ones. And we're told on an absolute basis, she answered 4 questions incorrectly. And then on a relative basis, we're told she answered 84% correctly. Right? So 2 different pieces of information for both of these kinds of questions, correct and incorrect questions that she had. And then they're asking how many did she answer correctly? So they're asking how many questions were answered correctly. We're given the number of questions that were incorrect. Now notice with this, we can fill in some more information here. If she answered 84% correctly, then that means she answered how many incorrectly? 16%. Right? 100 minus 84. The whole test is out of 100%. So it's broken down into 84% correct questions, 16% incorrect questions. And then actually from here, what we can do is with these 2 pieces of data, we can find out what the test is out of, how many marks the test is out of. And then once we know how many marks the test is out of, we can find out how many correct questions there are in terms of marks, 84% of how many marks the whole test is out of. So what we can do is we can say we know that the number of incorrect questions is going to equal the total marks the test is out of times 16%, 0.16. Right? The total marks the test is out of, 16% of those is going to be the number of incorrect questions she got. And we know the number of incorrect questions she got is 4. The total marks we're solving for, and then we got 0.16 here, so we could divide both sides by 0.16 to get that x value, and when you do that, you'd end up with 25. So this test was out of 25 marks. And so now that we know that, we can find out what the number of correct questions is. It's going to be the total marks the test is out of times 0.84. She got 84% on the test. So the total marks is 25 times 0.84, which would give us 21. So that's the number of questions that she answered correctly. So this here ends up being 21 questions. Right? So 21 out of 25 is 84%. And then notice that if the whole test is out of 25 marks, she answered 21 questions correctly. Each question is worth 1 mark. That means there's 4 questions that are left over that she answered incorrectly. Right, so that's how you do number 1. Now, number 2, it's going to be more tricky. I'm going to leave this same diagram because we're given a little bit less information. We're told that she scored 62.5% and answered 18 more correct questions than incorrect ones. So what we can do here, we know that she answered 62.5% this 62 1/2, I'm going to change to a decimal, 62.5%. We know she answered this many correct questions, and we're told that she answered 18 more correct questions than incorrect ones. So what we can do, if we let x equal, we can do either the number of incorrect or correct questions. They're asking for how many marks was the test out of. Yeah, so we'll let x equal the number of correct questions that she got. Okay, so this here is going to be x, which means that if she got this many marks for the correct questions, x, she answered 18 more correct questions than incorrect ones. That means that there are x minus 18 questions that she got incorrect. Right? That's the relationship that we can make with this one variable over here. And now what we want to do is we want to try to make an equation somehow to solve for this x. Now, we're told that she got 62.5% correct, which means what percentage did she get incorrect? That means that she got 0.37 or 37.5% incorrect, right? Both of these are adding up to 100. Now, what we can do here is we can try to create some equations where we're going to end up solving for this x. Now, that's not what the answer is going to be, because we're actually solving how many marks the total test was out of. So it's actually going to be the sum of these over here. So if anything, what we can do, we can actually introduce another variable, and let's call it y. We'll say that the test is out of y marks. So y is the total marks. Now to bring back those, you know what, let me actually erase this up here, give myself some more room. To bring back that relationship that we talked about in number 1, or the two relationships, we said what? The number of correct questions was equal to what? The total marks times, in this case, 62.5%. If we convert that to a decimal, 0.625. And then the number of incorrect questions is equal to the total marks times 0.375. That's the percentage she got incorrect. And so notice that we can plug in these variables here. The number of correct questions is x. That's what we let x be. So we'll have x equals the total marks. We're introducing another variable, y. So y would go here. So it would be 0.625y, which makes sense. 0.625 times the total marks, y, is equal to the number of marks that she got from answering the questions correctly, the number of correct questions. And then the number of incorrect questions, which is this x minus 18, is equal to the total marks, which is y, times 0.375. So we'll have 0.375y. Like that. And so from here, what we have is two equations and then two unknowns. And so we can solve for either x or y. Eventually, the final answer is going to be y, but it may be useful to first solve for x if it's easier, but I actually think that it may be easier to just solve for y. We can take this and plug it in for this x. So if we do that, we'll have 0.625y minus 18 is equal to 0.375y, like that. And so from here, we could bring the negative 18 over, bring this over, 0.625y minus 0.375y. Let me just actually write it out here. Like that. What's that equal to? This is going to equal 0.25. Y. 18. 0.25, divide both sides by 0.25. And we get 72. And so that's actually the final answer. This test was out of 72 marks. And we can check it. We can check our answer. What is 62.5% of 72? 0.625 times 72. This would give us 45. And then, what is 37.5%, the number of incorrect questions? 0.375 times 72 would give us 27. And what's the difference between these? 45 minus 27 is 18, which is what we're told in the question. She answered 18 more correct questions than incorrect questions, right? And she got 62.5%. So it all checks out. You could do a final check with these kinds of questions. All right, so the final answer for number 2, again, number 2 is a little bit more tricky. There's less information given, but once you do all the work, 72 marks is the final answer.